All right, section 3.5 is showing lines are parallel. So up until this point, in section 3.3, we said that if two lines are parallel, then we know certain things about our angle relationships. For example, corresponding alternate interior and alternate exterior angles are congruent, and we know that same side interior angles add up to 180. We're going to do the opposite today. And when I mean opposite, I mean the converse. So converse is a statement formed by switching the hypothesis and conclusion of an if-then statement. Remember, hypothesis comes after the if, conclusion comes after the then. Now, the converse is not always a true statement. For example, if you live in Sacramento, then you live in California. So the converse, I'm going to switch the hypothesis and the conclusion. So if you live in Sacramento, then you live in California, the converse reads, if you live in California, then you live in Sacramento. And that's not true, right? It's not necessarily true. It might be true sometimes, but not all the time. So this is false. Another example, if two segments are congruent, then two segments have the same length. So if I switch the hypothesis and conclusion, the converse reads, if two segments have the same length, then two segments are congruent. And that is true. If two parallel lines are cut by a transversal, then corresponding angles are congruent. And this is what we're going to look at further today. The converse says that if corresponding angles are congruent, then two parallel lines are cut by the transversal. So I just switched my hypothesis and conclusion. And that is true. And that's what we're going to learn today. One last example, if two angles have the same measure, then the two angles are congruent. So if we switch those, we get the converse, which is if two angles are congruent, then two angles have the same measure. And that is true as well. So we're going to look at 4 different converses today. So the first one is a corresponding angle converse, which says if two lines are cut by a transversal so that corresponding angles are congruent, then we know that the lines are parallel. So for example, here we know that angle 1 is congruent to angle 5 and their corresponding angles. Therefore, I can conclude that line R is parallel to line S. So in this example, we have two corresponding angles that are congruent. These are corresponding because they're both in the bottom left-hand corner. Therefore, I can conclude that these two lines are parallel by the corresponding angles converse. Okay, here we only know one angle measure. Now, you want to see if you can gather any additional information. So we do know that vertical angles are congruent. So we do know that this angle measure is also 60 degrees. But we don't know anything about these 4 angles. So we don't know anything about these two corresponding angles, or these two, or these two, or these two, right? We don't know anything about corresponding angles being congruent because we only know those 2 angle measures, and those are vertical angles. So we do not have enough information to conclude that these lines are parallel. Again, you want to see what additional information you can gather. Now, we do know that there's 180 total degrees in a line. So since this angle measures 80 degrees, we know that this angle measures 100 degrees because these two angles make a straight line. They're a linear pair. So now we do have a set of corresponding angles that are congruent because they're the same measure. So we can conclude that those two lines are parallel by the corresponding angles converse. These are two corresponding angles because they're both in the bottom right-hand corner, so they're in the same position, and they're congruent. So yes, we can conclude that these two lines are parallel by the corresponding angles converse. Okay. Here, at right now, we can't say that they're parallel, but let's see what additional information we have. We do know vertical angles are congruent, so this one's also 130 and this one is 50 degrees. They're across from each other. They're vertical angles, so they're congruent. But we don't know anything about the 4 angles down here. Therefore, we have no pairs of corresponding angles that are congruent. So we can't say that these 2 lines are parallel because there's not enough information. We don't have any corresponding angles. Okay. In this example, if one angle is 90 degrees, we learned in section 3.2 that all 4 angles are 90 degrees, and same thing over here. So we actually have 4 pairs of corresponding angles that are all congruent here. So yes, I can conclude that the 2 lines are parallel by the corresponding angles converse. Next, we have alternate interior angles converse and alternate exterior angles converse. So if 2 alternate interior angles are congruent, then I can say that my 2 lines are parallel. And same thing, if I have 2 alternate exterior angles that are congruent, I can say that my lines are parallel. So for example, I have 2 alternate interior angles that are marked congruent here, so I can conclude that M is parallel to N. So yes, by the alternate interior angles converse. Here we have 2 vertical angles that are marked congruent, but we don't know anything about these 2 angle measures, and we don't know anything about these 4. So we don't have any corresponding angles, we don't have any alternate interior angles, and we don't have any alternate exterior angles either. So there's not enough information to conclude that M is parallel to N. Do we have enough information to say that C is parallel to D? Yes, these are alternate exterior angles that are congruent. So by the alternate exterior angles converse, we can say that C is parallel to line D. And the last one is the same side interior angles converse, and this says that if 2 same side interior angles add up to 180, remember that same side interior angles are supplementary. So if they're supplementary and they add up to 180, then I can conclude that R is parallel to S. So find the value of X that would make J parallel to K. So we want to know what value of X is going to make these 2 same side interior angles add up to 180. So let's add them together and set them equal to 180, right? What value of X is going to make them supplementary? So subtract 115 from both sides, and we get 5x equals 65. Divide both sides by 5, and we get x equals 13. So when x is 13, if you plug 13 in for x, we get 65 degrees. So then 65 plus 115 gives you 180. So that is the value of x that would make these lines parallel. Same thing here. Find the value of x so that v is parallel to w. So we're going to add these same side supplementary angles together, same side interior angles together, and they're going to equal 180 because they're supplementary. So 2x equals 110. Divide both sides by 2, and we get x equals 55. So if x is 55, then this angle measure is 2 times 55, which is 110 degrees, and we know 110 plus 70 degrees would make these same side interior angles supplementary, which in turn would make V parallel to line W. Again, find the value of x so that v is parallel to w. So we're going to add these two same side interior angles together, and we want to know what value of x is going to make them add up to 180. So combine like terms. 4 plus 2 is 6x. Divide both sides by 6, and we get x equals 30. So if you plug x back in, 2 times 30 means that this angle is 60 degrees, and 4 times 30 means that this angle is 120 degrees, and you can see that they do add up to 180, and that's how you can check your work to make sure that your x value is correct. Last one. These two same side interior angles need to add up to 180. So x plus 22 plus 90, don't forget to add in the 90, equals 180. So x plus 112, equals 180. So we're going to subtract 112 from both sides, and x equals 68. So if you plug in 68 here just to check your work, 68 plus 22 is 90. So if this angle is 90 and this angle is 90 and we add them together, they add up to 180 degrees.